No. Okay, so in 5.3, number 48, they tell me that a Richter scale of an earthquake was 7.8. Yeah, so 7.8 is knocking down hardened structures, right?
Yeah, definitely.
This is, yeah. This is knocking down big stuff. So what they're asking is, how many times more powerful was this thing than a standard amplitude wave, right? So like, good question. Totally doesn't matter.
4.0.
No.
3.0.
0.
0.
So, how did I get to a Richter scale from an amplitude? You guys remember what I told you to do?
No.
Yeah, the Richter scale was just a log of the amplitude. Oh, yeah. Okay, so another way you could think about that log of the amplitude, that thing's measured in something, right? So another way you could do that is you could think about that as the log of the amplitude divided by some standard. Just to put the units in the right spot. Okay, so if they got 7.8, right? Is that a Richter scale or an amplitude? Richter scale. So you put that here. So you got 7.8 is the log of A over A naught. Right, the log of the amplitude you saw divided by some reference thing. And then what? You need to get the log out of there.
10 to the 7.8.
Yeah, bust the log out of there by hitting it on both sides with a 10 to the stuff. Right? Remember, every increase of 1 on the Richter scale counts a power of 10, right?
Yeah.
So this is going to be 10 to the 7.8 equals A over A naught, which will tell you 10 to the 7.8 times A naught is your amplitude A. So A naught is just whatever the reference was. So this is, it was 10 to the 7.8 times as powerful as the reference. You guys good with it?
Good with you.
How much more powerful was this 7.8 than say a 5.8? 100 times. 2 powers of 10, right? You went from one factor of 10 to get from 5.8 to 6.8, and then another one to get from 6.8 to 7.8.
It's really crazy when you think about that.
You guys cool with that? So, fun story. The most ridiculous answer I've ever gotten on a math test was in the first pre-calculus class I ever taught. There was a question which was like, the amplitude of an earthquake is 9.5 times the reference amplitude. What does the earthquake measure on the Richter scale? Say what now?
It's a 9.5. Yeah.
Oh no. The answer I got was,
It's not 9.5.
so y is 10 raised to the 950 a ridiculous answer?
On the Richter scale?
On the Richter scale.
A magnitude of 10 to the 950 would be
So it's not a magnitude of 10 to the 950, right? This student told me this was a 10 to the 950 on the Richter scale.
So the universe would be destroyed.
Yes!
Or maybe they.
I spent a second configuring this out, right? Because the amplitude of this thing would be, right? 10
With
to that,
900.
right? 10 to the 10 to the 950
And that's so far back and forth.
in nanometers or whatever, right? It should be noted that the universe is about 10 to the 33rd nanometers wide.
As far as
Well, yeah.
I think we're pretty confident on that one, actually. So our observable universe is 10 to the 33rd nanometers wide.
Break the universe.
So this thing takes a chunk of the universe, right? A little chunk of the planet Earth,
Just
and wings it out
into the multiverse.
well past the diameter of the universe. And then the kicker is
Comes
it
back.
brings it back,
Boomerang.
right? So if this thing goes out, that's a problem. When it comes back,
What's it gonna be like?
you got a bigger problem. Because if that hits the planet,
all that's left.
there's not going to be anything left after that collision. So the amount of energy required to move a particle this far in finite time would probably vaporize our galaxy, much less the planet. Which is cool to think about. So what should the answer of this be? Like if it's 9.5 times the reference amplitude, what would you expect it to be on the Richter scale?
Sorry, what was your question?
So to get from the reference amplitude to 1 on the Richter scale, right, the reference amplitude is a 0. To get to a 1, what do you need to do?
Raise it to the power of 10.
Yeah, that's 1 power of 10. You go up by a factor of 10. Has this gone up by a factor of 10?
Not
It's
yet.
gone up a lot more than that.
No, it's gone up less than a factor of 10 because it's only gone up 9.5.
So it's,
Right? 9.5 is smaller than 10.
so it's like.
Oh, so it hasn't gone up a factor of 10. It's gone
Yeah.
up a factor of 9.5.
It hasn't gone up a factor of 10 yet. It's only gone up a factor of 9.5. So I'd expect this to be just a bit.
It's gonna be 0.95.
I would expect this to be just a little bit smaller than 1. It's
Yeah.
not quite 0.95 because it's not multiplication, but it's damn close. So,
Oh, I see. Yeah.
right, I would expect this to be
10
the
10
log
10 would be
of
9.5.
9.5,
10 would be 1.
which is just a little bit smaller than 1.
That makes sense.
You guys see that?
Mhm.
So the real answer to this, oh, sorry. I was going to write A for answer, but it's actually R for Richter scale, right?
Yeah.
The result on the Richter scale is
0.97.
0.97. So it doesn't even make a full point. Let's go with that.
It's a very weak.
If it was 95 times the reference amplitude, what would I expect?
A 9.5. No, no.
Or two.
1.95.
Yeah, I would expect basically 2, right?
2. Yeah.
You guys with me on that?
Mhm.
Because 95 is almost 100, and 100 is 10 squared.
Right.
If it was 950,
That would be
that would be about 3, right? You guys see that?